Hi, everyone. We're going to get started shortly. I'm going to give it about 10 more seconds for people to come in, and then we're going to kick it off. Thank you so much for joining us today. Hello, everyone. Thank you for joining us today. For this webinar, we are doing on strategic energy management with fault detection and diagnostics, a roadmap to decarbonization. So welcome. It's great to have you all here. I'll be very quickly here with just some housekeeping. So today, the topic is we're going to explore how FDD is transforming energy management in buildings and basically paving the way for meaningful decarbonization efforts. And then Dennis is also going to share some of the exciting new EIS dashboards that have been released at Clockworks to kind of show you some of this in action. And before I pass it off to Dennis, I just want to let you know to please feel free to submit questions as they arrive through the Q&A feature. You should see that little chat feature. The chat is just a chat, so please know that that's different from Q&A. So if you have a question that you want Dennis or the team to address, please put it in the Q&A, and we'll do our best to field them as we go and keep it really collaborative and address the questions where it makes sense. Otherwise, I will open it up to an open Q&A at the end, so don't worry if you didn't get it in or you think of something at the end, there will be time for that. One more little housekeeping measure is you'll notice on the bottom right of your screen, the screen share, next to the closed caption button, there is a little like full screen icon. And I always recommend that to expand the view, especially if we're sharing dashboards or things with really tiny font. It's just a handy trick to be able to expand the view and just see some of those things when Dennis is screen sharing a little bigger. But do know that you have to minimize that back if you want to see the Q&A and chat app and to be able to submit your questions. So I will leave it at that. And without further ado, I'd like to welcome the VP of Product for Clockworks Analytics, Dennis Krieger, to the stage. Hi, Dennis.
Hello. Hey, thank you, Sarah. Hello, everyone. Thanks for joining us today. Like Sarah said, we're going to be talking about strategic energy management through kind of a unique lens, right? We're going to be talking about it through the lens of how can we deploy tools that help us actually achieve, what strategic energy management says you should be doing as a process, as a better way for managing energy in your buildings. By way of introduction here, Dennis Krieger, like Sarah said, I lead product development efforts here at Clockworks. I still claim to be a mechanical engineer at the end of the day, and I've been doing energy efficiency stuff in buildings for a little over 15 years now, starting out as an engineering consultant, kind of crawling around mechanical rooms and looking for ways to save energy. The last 10 years trying to kind of automate a lot of those manual tasks that we all know can be done, where you're trying to really at scale do energy management across many buildings. And full disclosure, dealing with a sick kid today. So if you see me run out of the room and go off camera, something is going wrong across the way here. So bear with me if I have to take a quick break. Clockworks, if you haven't met Clockworks before, we are a fault detection and diagnostics software application. We launched also about 15 years ago in 2010. Currently, we have over 3,200 buildings connected to the application spread across the globe. And that last bullet's probably the one that we're going to focus on the most today. We've seen over 50,000 completed tasks in Clockworks that represent over $50 million in annual energy savings. So we want to talk about how, again, tools can help you achieve your strategic energy management goals. And we'll talk about how Clockworks has some features that help you do that as well. I'm going to break out the webinar today into 4 chunks. I'm going to do my best to define strategic energy management in this toolkit approach that I'm talking about. I want to kind of demystify things and talk about how we actually deploy and set up these tools in existing buildings, which can be kind of interesting. And then we'll go through and kind of walk through what it's like to implement a new strategic energy management program across an organization. And last but certainly not least, I will take you into Clockworks and we'll click around. We'll show you what it looks like and feels like to actually do this within an application like Clockworks. So here we go. Strategic energy management, the toolkit here. I am going to steal the definition straight from the Department of Energy who wrote it here. Strategic energy management is simply a set of processes that empower an organization to implement energy management actions and consistently achieve energy performance improvements. My favorite visual is the one on the left here, where it's all about having a commitment at the very top and then getting to the point where you're working through this cyclical process of implementing changes in your buildings, verifying that those changes are doing what they're supposed to be doing, saving energy, and then continuing to do that. And this cycle never ends. Buildings will continuously break and find ways to deviate from their ideal state. So strategic energy management is really about the consistency of doing this over time. And again, we're going to talk about how tools can help you with that. Acronym number 2, I'm going to throw a lot of acronyms at you in this section, is Energy Management and Information Systems. Again, this is something defined by our friends over at the DOE as a broad family of tools and services used to manage commercial building energy use. So the way I think about it is, strategic energy management is your process. Energy management and information systems are the toolkits that can help you achieve that process. And you'll see here that the tools that the DOE specifies here range from doing monthly building analytics through to fault detection diagnostics. Today, we're really going to focus on the middle two. I want to hone in on energy information systems, which is really all about analyzing meter data, utility meter data from the building, and fault detection and diagnostics, which helps you really hone in on the problems within your building and gives you a clear kind of action plan on what you need to do to fix them. So we're going to talk about those the most. And again, lots of acronyms to get through, but the way I think of energy information systems is more of a top-down view of your buildings and the energy performance within them. So it allows you to automate a lot of the work of collecting the energy data to begin with, and then getting to the point where you have a way to detect anomalies in that performance. And so we'll talk about things like model predicted energy, this idea that the energy information system tool should be able to kind of model and predict where you should be each day versus the actual consumption that we're seeing from the meter itself. And so energy information systems, and in my simplified mind here, allow you to see things like this. Building 2 here might have exceeded what we predicted its energy consumption should be by 20% or 15%. Maybe that's costing you $1,000 or $500, right? Energy information systems allow you to kind of zoom out and see that and hopefully act on that information very quickly. But tool number 2 is kind of flipping that around. Fault detection and diagnostics is more of a kind of bottom-up approach. So instead of looking at the building holistically, we're now getting down into individual systems, individual equipment, and even components within that equipment. So your fault detection and diagnostics tool here should be able to look at an individual air handling unit. It should be able to see what data comes off of that equipment that can be used to get into these types of insights. So instead of saying my whole building is wasting energy, I can say this air handler is wasting energy, and it's because we have a problem here. You have a valve that might be leaking hot water into the coil when it shouldn't be allowing that hot water to enter that coil. So these are much more precise findings that can help explain why your whole building consumption was higher than it should be. And stealing my own thunder here, we're going to talk a lot about combining these tools right into one place. So you have the top-down view of overall performance alongside a very precise to-do list every single day of what's going on that's causing those meters to be higher than they should. So again, lots of acronyms. If you want to have a little cheat sheet, screenshot this because I might be using the alphabet soup here quite a bit as we get into the presentation. Strategic Energy Management, SEM, is the process. Energy Management and Information Systems, EMIS, is the toolkit. And we're going to be focusing on two very specific tools today: energy information systems and fault detection and diagnostics. That was a lot, but I wanted to start out with just common vocabulary here. So I'm not saying stuff that people don't understand. A lot more information on the DOE's website here. If you want to dig into these definitions more, I highly encourage you to go look at their Smart Energy Analytics campaign, where a lot of this material is put together. All right, so now that we kind of understand what the toolkit itself is, let's talk about how to actually deploy these strategic energy management tools. Because before we can get to the fun part here of actually changing the way that we're working with operations teams, we need to get the tools set up, and we need to make sure that they're useful for everyone that's trying to change the way that they're doing work. So these steps are critical. I see these as prerequisites, right, to really launching a new strategic energy management process within your portfolio of buildings. Kind of kicking things off with a pretty technical diagram here, but step one for any SEM tool is to get data. We're trying to automate a lot of the processes that we know we should be doing each and every day across many buildings. Primarily automating the collection of data and the ability to analyze that data so that we can find out what's going on in our buildings. This first step is pretty common. Lots of these SEM tools are going to do this in slightly different ways. Within Clockworks, what you see here is representing us deploying a local software application. It's kind of this thing in the middle on the computer, right? And its goal in life is to go speak to the devices within the building that we're connecting to. A device can be a controller on an air handling unit, and that controller is going to have many data points, things like temperatures, valve positions, flow rates that can be used in the analysis that we're trying to run. That same software application is also speaking to energy meters that kind of live within the building. And the goal is to read data off of those devices every 5 minutes. So we get a nice trend of performance throughout the day. And we push that up, in our case, to our cloud environment where it is stored. But simply put, if you can't get data out of the building, if you can't access the data in the building, obviously your tool is not going to do much for you. So this is just kind of establishing the tap here, the connection to get data streaming into the environment where you need to store it and put it to use, right? So connect is step one. Step two is to make sense of that data. And this is probably an often overlooked and frankly pretty challenging step in the process. That's really important, where we're taking this device that represents a controller on this air handler, for example. And when we start, we just know that that device has a name called AHU_03. And for anyone who's done this and knows our industry well, you also know that there's no standard for how we name devices, name data points that's been deployed across all these buildings that we're trying to connect to. So this step of modeling equipment is really about, adding this additional metadata. How do I classify this device as an air handling unit so that the application, my tool here, understands what it's looking at? Same thing applies to the individual data points that we can collect off of this air handling unit. So again, the temperatures, the flow rates, the valve positions, those are all going to have unique names kind of out in the wild of all the buildings that we're connecting to. We need to make sure that the tools we're deploying to support our strategic energy management goals here have a means of using this data in a very uniform way. So transforming the data itself into a consistently kind of named and classified model is a critical step as well. And then lastly, we go beyond what you can kind of get to digitally in a building, meaning I can read these data points off of the controller pretty easily, but there's gonna be a lot of information that is kind of left in PDF documents and mechanical schedules and things that kind of come out of the design, construction of the building that are going to be useful to unlocking the most capabilities possible in these SEM tools that we develop. So equipment schedules can tell me, how big the equipment is. Control sequences might tell me how it was designed to operate, so we have an understanding of what the ideal state is, right, for this particular piece of equipment. I want to answer questions on the fly here if I can catch them. I see the question on who installs controllers, sensors, and instrumentation. To be clear, everything we're connecting to in this building already exists, meaning when you deploy these new tools, we're taking what you already have, which are usually the building management system, the controllers within it, the data points that we have available there, and we're simply collecting data off of those. So we don't need new sensors, we don't need new hardware at all in this situation. All we need is to get to what can be thousands of data points in the existing building control system, and we start to read that data every 5 minutes, right? So we're simply taking what you already have and kind of finding all the gold within it, all the problems that we can identify with a more advanced analysis of what's going on across all of these controllers. Hopefully that answers that question. Again, the only thing that you add is a software application that can speak and talk to these devices every 5 minutes. So we've got this digital model established. Last step in the process is kind of turning on the tool, right? So if you've got a nice digital model, we can now use that to automate a lot of the steps that we're going to get into that are required for strategic energy management, particularly around how we can, at scale, run really advanced analytics that can help us give people a very actionable list of the highest impact things they can do each day that are going to help them achieve those energy goals that they're setting through strategic energy management. So again, in summary here, connect to the building, get that data established, create a nice digital model of how each equipment is set up, and then your SEM toolkit can really take advantage, right, of what's been established there. But this is still a prereq to the rest of the stuff I'm going to be talking about today, so I didn't want to skip over just how we're doing this, right? How we're getting to the point where I have thousands of data points collected on a single building and can get to the insights that we're about to talk about. Hopefully that makes sense. All right. Next up, section 3 here of the webinar. How do we actually implement strategic energy management and combine the process that is kind of dictated by this SEM approach with the toolkit that helps us do this at scale and without a bunch of manual effort and work? So what I'm hoping to do here is kind of break down step by step what the strategic energy management kind of flow looks like over here on the left, right? And how these tools can be leveraged to accomplish each of these steps. And then we'll go look at it in a demo towards the end of the webinar here. But first things first, you know, every strategic energy management program starts with making a commitment. I'm a little biased here. I think this is probably the easiest step in the whole process. And you've seen this done across many organizations where, you know, we're committed to being net zero by this year. We're committed to reducing our energy consumption by this percentage, right? So whatever your commitment is, at the end of the day, it's going to relate to reducing energy consumption and maintaining that ideal state, which I think becomes the most challenging part as you start to actually see your energy goals realized. It's very easy to quickly and aggressively deviate from your energy targets if you're not careful with the way that you're maintaining this over time. Second question, though, to the operations team is, well, how are we going to do this? And I think this is kind of the critical gap that we need to bridge with the tools that we're about to talk about. So if the organization is committed to being net zero, at the end of the day, you're going to need to connect that goal to the people who are actually operating and managing and maintaining these buildings. So a lot of what I want to focus on is how we connect these higher level goals to the daily activities that drive corrective actions in the building itself. And I think if you can't connect those two things together, you're going to have a lofty goal that is never achieved if the people doing the work aren't following along and kind of contributing to those goals. So how do we connect an aggressive goal to the operations team? Strategic energy management process says your next step is to benchmark your current performance and set goals against that. Well, for me, I instantly think of tool number 1, another acronym we already talked about, this energy information system. So part of assessing performance is to actually measure and quantify your energy consumption at the entire organization level. Now, of course, you can do that with utility bills. I'd like to focus more on doing it with interval meter data, because if you can get to more like a live data view, you can align what's happening at the meter with the problems that are causing that, meaning the equipment in the building that has a problem, right? So we're going to talk a lot about EIS in the terms of these abilities to roll up meter data dynamically and drill into areas across many buildings where you're seeing drift, you're seeing problems emerge because your energy consumption is climbing, right? Now, this type of goal where we're talking about KBTU or KWH kind of makes sense at the corporate level, but I also like to translate that into something that an operations team can appreciate. And I think this, again, is part of the biggest missing piece in a lot of these strategic energy management programs that you see. It's easy to talk, if I'm an energy manager, if I know how to look at meter data, I can speak KWH or KBTU or therms of heating, right? But the operations team speaks in terms of work orders and complaints and projects that they need to complete, right? And so one of the kind of, I guess, pro tip number one I'll start with here is that you need to be able to convert the goals of, you know, this energy performance into clear and aligned goals for the operations team. And for a lot of our customers, what speaks the loudest when it comes to energy is dollars being wasted or dollars that could be saved if you were to implement better ways of controlling the building. And so you'll see on this scoreboard here, this is something that we usually deliver to, you know, lots of our clients who are starting out, where we can say, you know, not only are we going to focus on your energy goals and give you automated tools for knowing how many dollars are being wasted or how many dollars could be saved, but we're also going to combine that with your other operational priorities, meaning at the same time that same team is getting complaints about, you know, comfort on the third floor. They might be working in critical environments where a lab space is down because the equipment serving it isn't functioning correctly. And so you really need to respect the balance of energy, equipment reliability, things that are happening that could be leading to a premature failure event, and the indoor environment, things that are impacting indoor air quality or critical spaces. So one thing we try to work closely with our customers on is how to get a combined view that can prioritize across these kind of three pillars of energy, reliability, and the indoor environment itself, so that we have a combined prioritized list of work to do that can easily translate into an actual work order for the team to go complete. So once you've kind of translated that, once you've aligned the team to the common goals here, you can get to the action plan. And this is where the cycle starts, right? And this is where we're going to talk about tool number 2 in our toolkit, which is Fault Detection and Diagnostics, FDD. So simply put, the FDD solution should be able to automatically create and maintain a prioritized list of problems and opportunities across all of your buildings, right? So if you want to correlate, you know, hey, this utility meter says we're high on our consumption. Well, show me the top 10 things I can do right now that are going to help me with that problem. And it should be as simple as sorting a table. And we're going to show you what that looks and feels like here in a second, to the point where every single day you have your top 10 energy issues and opportunities shown and available to you so that you can work through those, again, in parallel with your reliability issues and your comfort issues. So Fault Detection and Diagnostics should be able to automatically roll this information up in a way that allows you to interact with it to the point where you're ready to create that action. So what we're going to focus on, especially in the demo today, is how we can kind of set up this environment as we get into the implementation of this work, where I like to think of it as like a one-to-many relationship between the user who's interacting with these tools, the technicians that are going to respond to these actions, and then of course the hundreds of buildings potentially that are going to be within this organization that's trying to adopt this change. And so I think key takeaway here is that the tools that you deploy should enable you to kind of not just kind of scale out the math that's happening in the tool itself, but also scale out the resources that you're devoting to changing the way that you're doing this work. You should be able to have centralized resources that can go out and create, tens of work orders in a week, let's say, depending on how many people they're working with. And I think that's one of the most powerful things about this kind of toolkit approach. If you can't get to the point where you're scaling out the resources, a lot of times you're going to be constrained by just humans and what they can accomplish in a single day, right? And so we'll talk more about how this centralized person is able to interact with these prioritized action plans every day, so they can, again, initiate and maintain this cycle of create the action and, again, get to the point where we see impact because of that. For us, implementing the action, especially in Clockworks here, it's a few clicks, and we try to keep it really simple. I'm going to demo this, so don't you have to squint too hard on the text here, but the idea is that that centralized user should be able to really dig into these problems, right? If I know that my building is using too much energy, let's focus then on the top energy issue that's been presented to me automatically by this tool. Let's open up the diagnostic report, and let's understand, using all the automated root cause analysis that these tools can offer, what was the problem? What do I need to fix? Show me all the data to support it, because we're a bunch of engineers here who like to validate all these findings and see where these issues occurred and how severe they were. So all that data we collect, presented back to you, and go automate all that really tricky math that tells me how much energy and how much waste this is causing, right? This is really hard to do in a manual way, but if your fault detection and diagnostics can tell the story of energy waste, it's really easy to align that to these strategic energy management goals, because this is clearly important and aligns to what you're trying to achieve. Then lastly, get to work. If you're not creating and completing a task, if you're not doing something in the building, you're never going to achieve that very strong commitment of being net zero by this year or reducing your energy consumption by 20%. So the toolkit better give you ways to create that action. A lot of time those actions should become actual work orders or actual projects that you're distributing out across your team. Maybe I'll pause for a couple questions I see coming in. Clockworks doing ASO, Advanced Supervisor, ASO, is that supervisory control that you're talking about, I assume? We focus really on the FDD and the EIS combo here that we're presenting. Haven't enabled control in buildings to date. And then final question, I think I just answered that one too. We'll talk about how we combine EIS and FDD, especially in the demo, and can get into the techniques we leverage for both of those. All right, back to the cycle. So once you've kind of established this ability to create this kind of automated action plan and actually get to work with a team, I think these final two, evaluating progress and kind of recognizing achievements, are also critical. And evaluating progress, I'm going to start at the absolute lowest level here, because one kind of, again, often overlooked value add, if you will, of these tools is that when you actually complete the work, there's now kind of this automated validation that the work is doing what it should do. It's actually fixing the underlying problem. Because if you have the fault detection diagnostics running every single day, well, then I complete my task, I can see automatically that that issue went away. And so part one of evaluating, like, are we getting what we expect out of all this work, is to know that there's a nice feedback loop now between the task or work order or project that you create and kind of what the data tells us the next day, right? Did we see that issue go away? And can we kind of claim the win here? Do we have a nice impact? And see that again, all the way back to the meter as we try to reduce that energy consumption. So at the lowest level, the expectation is that I complete the work the next day. I kind of have a clean slate. There's no problems being identified anymore. And that's instant validation that the work achieved what you were trying to do. As you kind of continue the cycle there, what this turns into, in my thinking, is kind of this inverted view of what continuous commissioning looks like. So anyone familiar with like the Lawrence Berkeley National Labs work on continuous commissioning is going to recognize that chart on the top. This is basically explaining that, you know, business as usual will result in buildings consuming more energy over time. A retro commissioning, hey, every few years we're gonna come take a look at this, we'll kind of help you. You'll get this sawtooth profile as you improve energy, walk away, it drifts back up, you come back, you try to do it again. Really what we're trying to achieve is the bottom of this scenario here, where you are continuously working to maintain and even go beyond your current energy performance and improve it. And in Clockworks, that again relates to how we speak to these operating teams and how we show them clearly, hey, every day you're not fixing the stuff in your action plan here, you're throwing away lots of dollars. And how can we help you find the root cause of these and convert this energy waste into an actual work order to go correct it. So we'll talk about, especially in the demo, this concept of having this automated way to roll up all the energy waste in your buildings with simple clicks to get to the worst thing. But again, regardless of how you present this, the goal is to make sure that the operating team itself has a nice scoreboard, a way to see that they're actually working on things that matter, to the point where we get to the final and most satisfying charts here, the impacts that these tools and this program can have at scale. So energy savings on the top, this comes from the Berkeley Smart Energy Analytics campaign that they did in partnership with the DOE. This is showing typical savings from deploying really a combined EIS and fault detection and diagnostics program. And you're seeing savings that grow over time. And I think that's a really common theme. You deploy these tools, you work through the low-hanging fruit, you get change management, get team to evolve and start to use them even more. And more you're working on the highest impact stuff every week, and that will naturally lead to the energy savings you're trying to achieve. So this is a great study. If you haven't Googled Smart Energy Analytics campaign, I'd highly recommend doing that. But I don't want to just think about energy. Again, we are working with people who are operating buildings who have energy as kind of a part-time job, right? They also have a lot of people complaining about the environment they're in, or they have critical equipment that's failing, that's creating fire drills. So the other win to really think about is the non-energy impacts. And ironically, even though we're talking about strategic energy management, I think the same kind of process, if you will naturally lead to operational savings, specifically, not having fire drills, being proactive and making sure your equipment is properly maintained, and spending more time on those high impact issues that can resolve a lot of your reactive work. So this is another great study. This one was done by the Pacific Northwest National Labs, where they kind of broke down the impacts of shifting from a reactive maintenance routine, where you're kind of waiting for the humans to complain or the equipment to fail, shifting from that mode of operation into something more proactive, where you're following guidance, right, from these tools that we're talking about. In every single day, you have your number 1, number 2, and number 3 issue right there, ready to go. So you'll see, I think this cycle, this whole SEM approach we're talking about, leads to these energy savings and these operational savings trends naturally, if you can, actually adopt the process here. I missed a lot of questions again. Sorry, I'm working bottom up. Dusty asked about CMMS integrations. That is our number 1 integration that we do. And I'll show you that in the demo real quick, actually. So we'll talk about how that centralized user who is working with many technicians across many buildings can check a box and say, as I work on this in Clockworks, also make it a work order in whatever CMMS system is being used. All right, I'm going to move on. I might come back to questions here at the end. I am going to jump into a demo. Look at the clock here. We have 20 minutes left. I wanted to end with this almost as a reminder to myself, to things I want to highlight as I jump into Clockworks. So we're going to kind of check the box here of what these tools should be able to do. I'm going to try to demonstrate that here in a minute with the actual demo. But on the energy information system side, we're going to be talking about collecting 5-minute utility meter data, being able to benchmark performance and model predicted energy use, and then presenting that in a way where it can be very dynamic. An energy manager can kind of slice and dice their views, look across buildings, drill into specific systems. EIS should really give you all the tools you need to automate and interact with that interval data, right? And then toolkit checklist on the right here, fault detection and diagnostics. Now we're shifting into data from the building management system, so all the HVAC equipment. You should have an automated and prioritized list, that action plan that aligns with what we're trying to do in SEM. You should be able to open that up and get to a root cause very quickly. And you should be able to act on that information, again, even to the point where you're automatically creating work orders across your team. So hopefully I'm going to hit on all these checks. If I don't, yell at me in the comments or ask a question. All righty. I'm going to navigate to a different screen here. And we're going to talk Clockworks here. So I'm going to do my best to keep the storytelling going here, but I do also want to speak to the features that you're going to be looking at along the way. Let me see if I can get my screen dialed in here. It doesn't seem to help. All right, we're going to leave it like that. All right, so entering Clockworks here, I just want to hit on, again, some of those checklists that I just showed you. And I want to start with this energy information system tool in the toolkit, right? Now for Clockworks, what that means is having the flexibility to configure a library of dashboards. So you can see here on the left, I have access to many dashboards, but the key thing here is that these dashboards can be shared across your organization so that everyone has the same view, the same way to interact with the information that we are creating and automating over time. So a dashboard in Clockworks is just a collection of these widgets that you see here. Users have a lot of flexibility in how they kind of curate their own dashboards and views of this information. And I think that's a critical check on that EIS tool. You should have the flexibility to set up your own views. You should have the flexibility to interact with these views and kind of change how you're looking across time or looking across assets across your organization. So when you were looking at this, all of the information you see here is built on top of the 5-minute interval meter data, right? So we're not talking about monthly utility bills here. We're talking about 5-minute interval data that we collect throughout the day. This is probably my favorite way to view that. I like to bundle it into weekly intervals, and I like to span a trailing amount of time. I think we have a lot of flexibility on how you want to benchmark and baseline your performance. But when you talk about continuous work, right, we're talking years of adopting and implementing these changes. I like to have a trailing window of time that just updates every week. So if I'm an energy manager who's participating in this program, trying to keep tabs on, are we actually moving the needle here? I know every single week that we complete, my scoreboard here just updates automatically. Now at the top level here, we're speaking energy terms, right? We're talking kBTUs and dollars and tons of carbon that are the equivalent emissions for all this energy that's being consumed. And then we're also normalizing the performance, which is really critical here. Anyone who's done a spreadsheet 8760 model where you're binning data into weather bins across a typical year, that's what's going on behind the scenes here. I could do a whole hour just on that and how that's done and automated in Clockworks. But this idea that I can compare the actual energy consumption, which is kind of the blue bars here that you see, to what that model predicts. Hey, on a typical, for this building, on the typical weather conditions that we just saw, this is where we would have thought you would be at that moment, right? And so by normalizing that performance and be able to compare to a predictive model, you can get more accurate ways of saying we are actually saving energy, right? The actual meter itself might be higher because it's hot outside, but given that comparison to other times in the year where it's been hot, we're actually doing better. That's how you can really start to see through all the noise of meters and how they change and evolve over time. I'm getting questions thrown at me. We generate the model predicted values in two different ways. Some users prefer a static baseline, meaning let's go all the way back to that first commitment step in strategic energy management. Your commitment might be to reduce energy consumption against a baseline year, like the year of 2019 or something like that. So the model itself can be comparing you to a static period of time and saying you've saved 5% against that baseline. The one I'm showing you now is a more dynamic window of time that moves with you. So you're kind of always comparing to, say, the trailing 12 months. And are we doing better than we have been in the past? Both are possible. Both kind of speak to different audiences in different ways. I personally like the dynamic window because it gives you a clear year over year, we're doing better, especially for operations teams. It kind of helps you compare to a more recent interval of time that might be more representative of what the building was set up to be doing. But all of that gets into binning that utility consumption and comparing it to the temperature range you were operating within, and making sure that we're trying to compare apples to apples for each of these. All right, just to round up the demo here, at the top, we're talking about whole building energy consumption. And again, we've done this across a connected portfolio of buildings. It's also worth pointing out that you can get into a similar approach by energy type. So if we're looking at electricity, we can do similar comparisons, look for anomalies that are just impacting electricity meters. If you're doing, say, purchased steam or purchased chilled water, we can do the same thing. So, steam spiking in the winter, chilled water spiking in the summer, as you'd expect. And again, by normalizing the consumption against those weather conditions, you can start to see those anomalies stand out, where you're actually consuming more than we'd expect based on either previous performance or, again, kind of that static baseline. Lots of questions here. How do you generate the model predicted values? So that gets back into, once that model is established, once we kind of understand what you're trying to compare against, every day we're collecting a new fresh batch of meter data. We're producing two values every day: the actual consumption, so just the sum of the meter consumption over time, as well as that model predicted value as its own calculated point. And we store that. We can plot it here on the dashboard like you've been seeing. And again, it's just using that kind of that typical year binning method that might require a follow-on technical summary of, if you guys want to get into that one. Matt asks, is Clockworks constrained to certain building types and activities? Is there equipment that this does not currently work for? I'll say we focus primarily on the equipment we can get to through the building management system. So when we talk about equipment in Clockworks, it's going to be air handlers, boilers, cooling systems, heat exchangers. And I'll say the more complex, I think the better with these tools. If you have a complex university campus with central utility plants, those are things that we can handle really well. But simple is good at scale as well. Like sometimes a simple building, but you have 1,000 of them, really justifies the deployment of these tools as well. So we're not really limited by equipment type, but we are focused on, again, the equipment that's connected and controlled by the building management system. Hopefully that makes sense. All right, I'm going to keep going here just for time and make sure that we get to the rest of the features. But again, this view that we're talking about is the kind of EIS view, and it speaks to a certain user who is comfortable speaking in the terms of kBTU and tons of carbon, right? But it's not going to speak to everyone. And so I also want to point out, again, this connection between operations team and maybe like the energy manager that might be participating in this program. and get into a kind of slightly different view where we are normalizing this for an operations team that might want to set goals across energy, but also across other performance issues that they're going to be responsible with, because they have one team, they have one list of to-do items that they're going to have to work through each week. And so we want to make sure that we're combining these energy goals with their other priorities. So this is an interesting dashboard that we introduced to a lot of our especially new customers kind of embarking on this journey of changing the way they do work. And what you see here is kind of just a different language. So instead of talking kBTU, I'd say most of our users speak in dollars, especially if they're trying to justify their own budgets in dollars to go fix these issues, right? So what you're seeing here, we kind of shifted, we zoomed in a little bit. We're looking at the last 30 days now of daily activity. What this is showing me is the number of dollars being wasted because we're not working on our action plan, essentially. We're not jumping into tool number 2, which I'm about to get into, and looking at what types of problems we could be fixing or what types of opportunities we could be pursuing to improve our energy performance. So knowing that in the last 30 days, we're throwing away like $80,000 is pretty motivating, right? Like the goal should be 0 there if we were working in our ideal state. And again, this kind of speaks to the continuous element of strategic energy management. Every day, something will change in this building. On large buildings, every day, something will probably break in the building that's going to cause a spike all of a sudden, right, in your energy waste. So if you do all this kind of energy management work, if you've got great plans and you're doing even capital projects, that's all great. If you're not staying on top of that every single day, that's where you see the drift. That's the classic, business as usual approach, just letting the building deviate from your ideal energy performance. So we're going to talk about how these numbers are calculated here in a second. I think there were some questions I skipped intentionally on energy waste and how that's kind of different than the normalization of that utility meter, right? This is much more specific to the events at the equipment and system level in the building, where those predictive energy consumption charts that we just looked at were for the whole building based on the meter itself. But again, this column here is one of 3, and the other 2 are really important to just keep in mind that I think strategic energy management gives you multiple wins, right? If you are doing this proactive work, you should also see improvements to equipment reliability and the problems that you might have there. And you should see improvements to your indoor environment, whether you talk about that in terms of comfort or maybe critical spaces that you're trying to kind of stay on top of. Now, this kind of view that we see here is something that you can drill into, and this kind of tees us up for tool number 2, which is diagnostics. So if you are looking at that dashboard, you should be able to go beyond and say, show me now the top 10 problems that I should go address, that I should go work on. That's exactly what fault detection and diagnostics is built for. So let's break down this feature real quick. I'll open one of these up and we'll get to the point where you can see how easy it is to go from the action plan here to the corrective action out in the field that you're kind of pushing your technicians to address. So first things first, this table again is filtered across all of my buildings. Like, don't forget that this can be hundreds of buildings condensed down to the top 10 things you should be focused on. It's also filtered across time, which is a really interesting thing to think about here. I think a lot of people in buildings think of critical alarms and the flooding toilet on the 3rd floor that requires your attention right now, right? I think with strategic energy management, it's not always critical stuff that we're talking about. It's things that you might need to address as a project. It's something that you might want to address on your next preventative maintenance routine that you have scheduled next month, right? And so I think fault detection and diagnostics should be able to keep track of all these problems as they change and evolve over time. And so this first thing on my list is a single air handling unit in one of my buildings. We're going to get into this list of problems that are occurring on it. It's by far wasting the most energy across all of my buildings. This is the single piece of equipment I should focus on the most if I want to address the energy waste that's occurring across these buildings. And we can see that these issues have been occurring. Each of these little bars represents a single day where we've collected all that data from the BMS and we've output your problems here. And the reason we kind of give you this little view is because a lot of these will change and evolve over time. You might have things that only flag on a weekend because you're operating outside of a weekend schedule. You might have things that only happen when temperature conditions are right. Think of like economizer problems or opportunities. And so being able to kind of keep tabs on that and roll it up across time, really interesting, really powerful, a lot different than just a flashing red light in your BMS that's talking about a critical alarm. This is more of an engineering analysis that's going to help you achieve those energy goals, right? Now, again, story time. Who's looking at this? I'm that user who's responsible for probably multiple technicians across these buildings. My goal is to convert this action plan into an actual task and a work order for someone who's going to go fix this. So your fault detection and diagnostics, if we kind of go back to that checklist of what should it be delivering to you, this is a really important click that I just did. This pulls up a report that is automatically generated that details out my problem, in this case, simultaneous heating and cooling. It also automatically tells me what the most likely cause of that problem is. In this case, a leaking valve that is allowing hot water to enter this coil when it shouldn't. Now that alone is really powerful. We just converted 30 days of 5-minute data into the worst problem across my buildings. And with one click, we're telling you exactly what's wrong. And that's what fault detection and diagnostics is doing. It's kind of removing the ambiguity around, hey, my building's 20% higher on the meter, and saying, well, here's the first thing I would do if you wanted to fix that, right? If you wanted to reduce that energy consumption. Now, I'm running out of time, so I'm going to scroll a little bit fast here, but it's not uncommon that you have problems that impact energy alongside problems that impact, say, comfort, like relative humidity not being maintained. That user, who's again kind of this centralized role, is going to read through these problems. They're going to see and validate the problems down to the granular data that we collected, views of, say, that leaking valve that we were told is our main problem here. So this chart here is kind of what that fault detection and diagnostics, the data that it used to reach the conclusion that we just read. This has a valve that's been in a closed state all day, yet I see an increase in temperature across the coil as air is moving across it. That's kind of the trick to the logic behind the fault that was generated. Here's the data that supports that finding. And lastly, I think I saw a question about like, how do we validate savings here? And how do we think about calculations of energy waste? This is a completely different methodology. In fact, if anyone does M&V techniques here, this would be like your type 2. Instead of looking at the meter in the whole building, we're looking at the data on the equipment, on the system, right, to do this calculation of energy waste. So what you see on these final two charts is an automated energy analysis of the problem that we just saw. So because you're heating air when you shouldn't be, we have a lot of excess heating happening here. So I have kind of this red line saying all of this heat that went into that unit was waste, followed by the downstream impact of that, which is your chilled water systems kind of making up for it. You have a cooling coil that's now removing all of that heat immediately downstream. So this is a classic simultaneous heating and cooling. We're using actual airflows and temperature changes that we're reading on this piece of equipment to do this level of calculation. And this kind of aligns now to the waste you'd expect to eliminate, right, if we go fix this problem. Maybe my last click of the demo here is to show you the easy button for getting to work. And this is where we talk about how can I get this event, right, into usually like the pocket of a technician, someone on a cell phone working within their existing work order system. And so that user in Clockworks who's able to prioritize all of this work across all these buildings, creates a task, assigns it to the appropriate person. And again, the main thing we try to integrate to is that work order system. So when I go and create this task, it can automatically become a work order system. But that human is still in the loop. And that's probably the final thing I'll say with 3 minutes to spare. It's really important to think of having that centralized resource who's still evaluating this action plan and being very intentional on what type of work order they're going to create, so you don't overwhelm those resources on the other side that are going to be responsible for tracking down this air handling unit and fixing the valve that's leaking, for example. With that, I have 2 minutes and I still have a lot of questions. Sarah, I'm just going to start answering questions until you stop me, I think. And if people can hang on, I think that might be good. Let's see. I'm going to have to go bottom up here. So next question, estimated dollar amount for energy costs, equipment costs. So the way that we're doing this in Clockworks here is we're modeling the cost structure of each building as we kind of bring it on. So if I'm looking at the building this air handling unit's in, we're going to track the utility cost for that building. And so those 2 charts I just showed you, where we're calculating the waste of energy for that air handling unit, we're going to compare that to the building's cost for electricity, natural gas, and then we're going to produce an annualized amount of money that could be saved if you were to go fix that problem. So it's quite a complex kind of projection of savings, and that's kind of the thing that we focus on as far as celebrating the wins with our users. Hey, good job implementing this new control sequence. Here's the dollars and the energy impacts and the carbon equivalents of that energy that you just achieved. And all that's done through the combination of that data we collected and then just comparing to the building's local utility rates. You also brought up another interesting one about equipment cost. We are also starting, this one's a trickier one, where we're starting to also help customers that want to do this opt into automated calculations for impacts to equipment life, thinking of things like cycling equipment, right? If I'm seeing excessive cycling on a piece of equipment, will that impact me financially when that equipment fails prematurely? So we just went from a 15-year life down to a 10-year life type thinking. I think that's a really interesting one that people can opt into, but requires a little fine tuning on some of the assumptions that we make on what those impacts mean to each customer. Matt asked an interesting one further up. Can you use Clockworks to evaluate a conceptual equipment change? This kind of gets into your fault detection and diagnostics tool, being able to find both problems like that leaking valve that we just looked at, but also opportunities for improvement. Most of the opportunities that we flag do give you this kind of conceptual, what if we were to change the way that we operate the building or the piece of equipment that we're modeling. Common examples of that would be adding a VFD, changing a control sequence, like implementing a reset schedule, modeling changes like optimal start-stop of equipment on the building, modeling better schedules, better set points. And so we do a lot of that. Replacing a boiler would be a bit more advanced. That's where you probably need to get into other tools that help our users do their own kind of custom capital planning analysis. Probably not something we would automatically like flag every day in our standard fault detection and diagnostic analysis that we run. But a lot of the control optimizations and simpler like ways to tweak and optimize your set points and sequences and schedules, those are automatically detected and again modeled to show you what the energy impact would be. Sarah, you tell me. I'm kind of cruising the list. I think I answered most of these.
Hopping on the stage. Yeah, you did address most of them at some point. And some of them I think we'll address in our follow-up. So just like where to get information specifically about Clockworks and access to these slides and things like that. So
Cool. Well, then maybe we'll follow up. I'll take a look at the questions offline here, maybe send out some more direct answers. Thanks everyone for staying with me for the hour. We covered a lot of ground, a lot of acronyms. Hope it was useful for everyone, and I'm sure Sarah will direct me on how to follow up and share this information out after the webinar today. So it's a fun time. Thanks for joining me.
thanks everyone. Have a good day.